Okay, for the next set of examples, we have the half-life of radium, which some of you might already know is 1690 years. If 10 grams is present now, how much will be left in 50 years? Well, again, radium, well, it doesn't say that, but radium obeys the law of uninhibited decay. So we're again using a formula like this. And this half-life will help us determine what K is. In fact, we don't even really need to know what A0 is to find what K is, because we can just say, well, 1/2 A0 is what we're going to have after 1690 years. So the A0s will cancel out, and so we get 1/2 equals e to the natural log of, K times 1690. And so the log of 1/2 is equal to K times 1690. And so K is going to be log of 1/2 divided by 1690. Okay. All right, so now we can just go ahead and we say if 10 grams is present now, how much will be left in 50 years? So this is where T is 50. A0 we now know is 10. So it's going to be 10 times e to the k, which is this big thing, okay, times t, which is 50. Okay. So we have this whole product here we're raising e to that. And so this is going, and when you plug everything in, this is approximately 9.797 years, or grams, I guess. Okay, which is not very, which is almost, so it doesn't change much in 50 years, because that's how a half-lives work. For example 4, we have a fossilized leaf that contains 70% of its normal amount of carbon-14. How old is the fossil? Okay, well, the half-life of carbon-14 is 5730 years. We needed that. We don't know, once again, we can do this whole thing that we did up here and just replace 1690 with, in this case, 5730, and we will get that K is the natural log of 1/2 divided by 5730. Okay, so our amount at time t, the amount of carbon in this fossil, is A0, it's our initial amount, times e raised to the log of 1/2 over 5730 times t. And we want to know how old is this fossil. So we're actually asking to find what t is when this amount is 70% of the initial amount. So that's 0.7 times A0 equals A0 times this number. Okay. And you can see it, we don't really care what A0 is, because we can divide both sides by A0. And we get 0.7 equals E raised to this number times T. So the log of 0.7 is equal to this number, which is still log of 1/2 over 5730 times T. So T will be log of 0.7 divided by this number. And so that's what we have. So this is going to be, this is equal to 2948.5 years. Okay, and that's this is an example of carbon dating. Now how they determine the age of a fossil.